Good afternoon, everyone. Welcome to our week 5 of MATH11246 Essentials of Applied Math. Before we begin, just want to remind you that next week is a midterm break, so there won't be any classes. Okay, so please bear in mind. I don't mind if you're coming in line Friday at 3 p.m., but don't expect me to be there. Yeah. Okay, let's begin. So week 5, what did we cover in week 4? We'll start with acknowledgement of the country. We respectfully acknowledge the traditional custodian of the lands on which we work and learn. We pay respect to First Nations people and their elders, past, present, and emerging, for they hold the memories, the tradition, the cultures, and hope of Aboriginal and Torres Strait Islanders people. Aboriginal and Torres Strait Islanders people should be aware that this course may contain images, voice, and names of deceased person. Right, so recap. Factorizing algebraic expression. Algebraic fraction operation, the plus minus, multiply, division kind of thing. Multiplication, division. Rationalizing the denominator. So if there are roots in a denominator, we rationalize it. Then we got addition and subtraction. So kind of all the operation, rationalizing, algebraic fraction operation, and it's factorizing. Okay. Week 5, let's begin. So first of all, equation. So equation and some general properties. So big chart here. What is the first one called? X minus 5 equals -2. Right? It's a linear equation, only one variable. Again, a linear equation, but more than one variable. Again, a linear equation, more than 2 variables. As you can see, 3 variables there. From here, what do we mean by linear equation? So any equation where the variable power is 1, right? If they are in reciprocal, we call it reciprocal equation. Then we got fraction, then any power 2 equation, right, will be called quadratic equation of one unknown. Then we got cubic. Then we got nth power polynomial of unknown x. And then the square root is called radical equations. So there are some type of equation, and it's expected that we are familiar with them. Okay. Right. So if you move a term from the one side to the other, so from left to right or from right to left, it will change its sign. What we mean by that, so if it is you have a +2 on the left-hand side, you move it 2 on the other side, it should be treated as -2, right? Example, move a term from one side to the another one. Okay, so let's say we move 3 from here to the other side. So how it should look? So 2x squared is equal to x squared plus 2x plus 5. This was -3. Move on the other side should become +3. Right? You can keep on simplifying if you want. X squared plus 2x, 5 plus 3 is 8. Okay, now we can move either everything here, or you can move the 2x squared on the other side. So what we do, move everything on the left. It just asks for one term, but we are doing extra. Okay? Nothing on the right-hand side, so becomes 0. 2x squared minus x squared, 80 is x squared minus 2x minus 8. And we have learned how to factorize this with the AC method. Yeah, product sum factor or the AC method, right? Okay. Let's talk about multiplication division. So common factor shared by both sides of the equation can be cancelled out, provided it's non-zero. But if it is already in a denominator, then it's non-zero. But if it's a numerator, before you cancel out, you need to make sure that that's not 0, right? For example, if I tell you x squared is equal to 3x, how do you solve this? Anyone?
Oh, you divide both sides by 3, therefore cancelling 3, making it x to the power 2 over 3.
Here by x. If you divide by 3, the 3 is still there, which you have to take on the right-hand side, so it doesn't help. But by x,
Answer it, my son. What about?
Yes, so divide by x. Very true, Daniel. You can divide by x, assuming your x is not 0. So you can say if x is 0, obviously this is a solution, right? If x is non-zero, then what you do? Divide by x. So this will become x, this will become 3x is equal to c. Or like Daniel suggested, right? That's a better approach. X squared minus 3x is 0. Bring it on the left. Change the sign. Take x common. X minus 3. Now multiplication of two factor is 0. So either the first one is 0 or the second one is 0. So either x is 0 or x is 3. Yeah, that's the same thing here as well. Okay. So be cautious when you cancel something. Okay, let's look at an example. 2x over x minus 2 is equal to x plus 2 over x minus 2. Since it's already in a denominator, we cancel it because it's a defined term. So it's obviously non-zero. So that means you can say 2x equals x plus 2, and we shift the x on the left, becomes negative. 2x minus x becomes x is equal to 2, right? Okay. If you have ax is equal to b, what we do, ax is equal to minus b, and then divide by a, assuming a is not 0. Okay, so in a linear equation, a will not be 0. Why? If it is 0, it's no more linear equation. Yeah, because then it's only b is equal to 0, whereas there is no x. So that's like a constant thing, right? So whenever you talk about linear quadratic, that's called a leading term. That will never be 0, right? Okay, solve for x. Like maybe questions, you can do it with me if you like. Right, what we do, shift the phi on this other side. It was minus phi, that will be treated as plus phi. Minus 2 plus phi, or phi minus 2 will give you 3. Okay. Up here, phi over x plus root 3 is 2. You multiply it and divide by 2. So you can add one step. Yeah, and therefore pi over 2 is my x plus root 3. Yeah, and phi over 2 minus root 3 is my x. Yeah, any luck?
Wi-Fi school bars, but I won't load Safari, Chrome, nothing. And
A restart might work. A restart. Oh, you did restart. Oh, okay. Okay. Next, solve for x. Give it a try, please.
oh yeah, I did my this.
Not here. Gabor, I love what you are doing, but the session is recorded. Okay, you can write the answer in the chat, right? Actually, You can. I would have done the same thing. If it's wrong, then I'll ask you to cancel it, right? Otherwise, keep going. Sorry. Yeah, I would have done the same thing. So that means everyone is involved. Yeah, go on.
The light. I was like,
That's fine. Daniel, you want to try the first one?
What, like write it on the?
Yeah. If you want to, yeah.
I don't know how to do that. How do I do that?
There is an annotate tool that you can pick up. So you see that bar where it says mic and video and participate and chat and everything. So if you keep going, there is an annotate pen thing. You pick that up. That will allow you to write on screen.
Mine only has record reactions, apps, whiteboards, and notes.
Okay. You don't see the mute and video and everything?
Yeah.
So 1, 2, 3, 4,
Oh,
5,
at the
6,
very
7.
yeah.
Seventh from the left. That should be, yes, there you are. See, now I got a company. Writing on a screen, your handwriting, you feel like, oh my God, it's not working the way I want. Right?
Horrible.
Honestly, I just had a support session for one of the other math unit, and I wrote it after a year on a big board in front of an audience, right? And that I feel like, oh, okay, my handwriting is not that bad. Yeah. Okay, cool. So we got the answers correct as is done by Daniel and Gabor. That's correct. So what you do, change the signs of 4x plus 6. I'll just write it again. So that's 14. So we are swapping this to, this goes here, this goes here. When you swap, please don't forget the plus or minus. If you want, I can write 8 plus 6. So 10x is 14 and x is 1.4 or 5 over 7. Don't leave 14 over 10 because that can be simplified. And again, I'm just writing it the same thing. Again, 5x is equal to 2 times x plus 3. So this is perfect. 2x plus 6. When you shift it, 3x is 6 and x is 2. Good job, everyone.
so when you do 5/7, isn't this supposed to be 7/5?
It is. Thank you. It is. I said it, but I wrote the other way. Now you'll have to clear your screen. I can do that, maybe annotate and then clear everything. How do I clear? Yeah, thank you. That's quick. Thank you. Right. Exponent and radical operation. Only positive results are allowed to come from any even radical operation. Only positive are allowed to come out. Okay. So give it a go. X squared plus 4 square root minus 3 is equal to x minus 2. You do have. You do have.
Trying to provide. It's finished. I was going to upload it. It's hard for me. I got into it. I just need to find it in the
I have a question. So I've gone to this point where I have x minus 3 is x. Am I able to like move? I got very wrong. Yeah.
Did you separate the square root to both of them?
Yeah.
No.
I would put in brackets and put it in and treat it like
I'll tell you one example, right? Okay. What is 1 plus 2 whole square?
I can't hear that. 1 plus 2 whole square. So it would be 3 squared. It would be 9.
Right.
Yeah.
And what about if you separate the square, 1 square plus 2 square? What is that?
It would be 5.
So 9 and 5 are the same.
Oh, so
So
I
you
should treat that as
can
a
never, you can never give individual square, square root, cube root. No. Yeah. And you are not the only one. At least half of the student does that mistake. Sometimes out of stress, sometimes unaware that that's not allowed, right?
I did my lunch type testing the other night, and I thought there'd be questions like this in it, and I was so excited. I was.
Which test?
Type of it.
Oh, yeah. The literacy, yes, yeah.
I was waiting to see surds everywhere and simplified, but no,
It's different, yeah.
it was very boring.
Okay. I'm not sure who was writing. Was it Daniel? Okay.
No, that's me.
Okay. Unfortunately, that's wrong.
It looks wrong as well. So.
From the first step, it's wrong. Right? And even if assuming your first step is right, can't you cancel your x square, like positive x square, negative x square? So you got 13 is equal to 4. What you got here is x square positive on the left, x square positive on the right one. That's not true. Yeah. So from your first step, you got 13 is equal to 4, and therefore something is wrong. You did the kind of similar mistake to what I was explaining here to Austin, that square root, you cannot give it individually. There is a better formula. For example, a plus b whole square is simply not a square plus b square. There is that middle term as well. So if you can cancel even that one, scrap that, please. No, that's not a whole square. No, not like that. Yeah, then it's 4 minus 3, then it's 1. Yeah, so get rid of the, yes, thank you. What you should do, the complex thing or complex term, when I mean complex is not the complex number, difficult term, leave it alone. Take the 3 on the other side. So that simplifies to x plus 1. Right? Now what do you do? How do you get rid of the square root?
Just elevate to the second.
Yes.
Power of 2 and the, oh,
Power
so
of 2.
first I saw
Very
first
good.
move away the stuff and after I move then to the second and not start with that one.
Okay. So now the next thing is squaring. Right? So square root of x square plus 4 square is x plus 1 square. Now one should realize here that this is half power. This is 2 power. Half and 2 will eventually cancel. Right? Power's power goes in multiplication. So when you multiply half times 2, they cancel out, leaving you with x squared plus 4 is equal to x squared plus 2x plus 1. Please remember that whenever you have a plus b whole square, that is a squared plus 2ab plus b squared. You cannot give individual square. I will feel very bad. And if I feel bad and I see it in the exam, I cut half or 1 marks. Of course, because that's the wrong step. Yeah. But not that I feel bad and I cut it, because that won't be correct anyway. So from here, you can get rid of the x square. We call it subtraction. So 4 minus 1 is 2x. We write 2x is 3. And therefore, x is 3 over 2.
This makes sense.
Thank you. Right. Now, a cautious word here. Whenever you get root or reciprocal or something inside something kind of composite function, always verify, either in your brain or on a piece of paper. Now, here, my root term is positive, so it's fine. I'm not worried about. But what if and I got x squared as well. But what if the question was x plus 4 and my x was negative 5? Then when I plug in, it becomes undefined. And that's why you have to verify or check whether your answer is valid or not. Right? In this instance, it's fine. Any doubt? Obviously, please raise it to me. Otherwise, I assume it's fine and we keep going. Both positive and negative results are allowed to come out of any odd operation, right? So 1/3, 1/5, 3 power, 5 power, they are fine. They will keep the negative, but something negative square, positive. Positive square, positive. Yeah. Please try that. Oops. This is a very tricky question, so please pay attention. Yeah. Unless you are expert in 3 power. Have some faith, have some confidence. You were already having the answer, but since I said it's a difficult question, you kind of, oh.
Oh, no, I actually didn't have the answer. I'm just like,
It's a one-step question. In order to remove 3 power, what do you do? Cube root. Oh, we say cube root. Yep, yep. That is the answer.
I keep on thinking, oh, I've got somehow simplified more, but
You can't.
I can only
So-
simplify it.
Yeah. Cube root. Cube and cube root. How about 3 or 1/3? Multiply by 30, you're multiplying the number. So when it comes to, that's called cube root, cube and cube root, 3 power and 1/3 root. Yeah. That's fine. As long as you understand what's happening, you won't have to explain what you've done. Is that a piece of paper? Yeah. Right. So because it's called cubical equation with 3 power, so cube and cube root, square and square root, 4th power and 4th root, 5th power and 5th root. Yeah. Yep. Yes. Yeah. Yeah. So yeah. Yeah. Cubical equation, cubical graph. Yeah. Yeah. Power of 3. We just had that table as well. I think when you are fixing that thing. Yeah. We had that chart. Yeah.
I just think that we do.
Good. Awesome. So that's a simple question, very simple question, right? Give it a go. Oh, sorry, Daniel, I'm not looking at the chat, but I see it now. Yeah, you got both the previous chat. It's on the screen, and like I have only control of 2 screen here. Yeah, if I'm working from my chamber, I have 3 screen. So one I keep the video participant, one I'm sharing, other I'm writing, Yeah. 2 or plus or minus 2? 2 or plus or minus 2? It will be 2. Or if it is square, if it was a square, then you have plus minus. Yeah, because what happened? Just take a step back. Why do we say square has a plus or minus? Because minus 2 square is also 4. Plus 2 square is also 4, right? But plus 2 power 3 is 8. And minus 2 power is minus 8. So they are not the same number. Yeah. Plus minus, dear. Plus minus, whosoever what. Oh, you know what? You can't see it there. He's writing on my screen, which you can't see.
I wasn't sure if I should look
Yeah,
up,
I was
but
gonna
like
say, I have no idea what writing you guys are talking about.
Oh, I didn't see that thing. Okay. So whatever you're writing here, good. But they can't say it because that's a presenter mode is different.
Oh, I'm happy, sir. They didn't see anything that I
The
like.
recording anyone watching the recording would be able to see that, but not the
No,
other parties.
before you started, I just started drawing like houses and stuff on the screen, so they didn't see that. That's nice. Okay, I'm
Not
happy now.
here, but it will be a part of recording.
Oh.
Don't worry. Don't worry. Okay. No, what you did is perfect. And that's why I have to, redo everything what is done. You can see it now. Okay. Right. Oh, thank you. You cleared the space for me. Oh my God. It's a so funny situation, right? So even in a previous example, because Daniel and Gabor has written on a screen, so they literally block the earlier upper part. And I can't rewrite over there, so I write them. Then I realize it now that, oh, you feel like there is so much space, but it's starting in a corner.
I just thought you were talking about like they had their own private screen that they were doing.
Yeah,
And
I thought they
Yeah.
were sharing their screen to you, and
Yeah.
that's why we couldn't see it.
No, they're writing on the screen, but I don't know why it's so. Technologies, yes. They're a blessing and a curse, like honestly. X square is 5, and therefore x is equal to plus or minus root 5. Yeah, like I was discussing here with Fiona, squares, when you take square root, will have plus or minus, but the cube, okay, in general, even power will have plus or minus, odd will not. Reason very obvious and simple, because minus 2 square is also 4, plus 2 square is 4. So when I take the square root of 4, I mean, when I say x square is 4, my x could be plus and minus 2, right? But when you look at the 3 power, similarly, you can talk about 4 and 5 and other power. I'm not talking about everything. 2 power 3 is 8. Minus 2 power 3 is minus 8. So they are different, right? And therefore, 8 cube root is only 2, not minus 2. Yeah. Okay. Yep.
So when we do like an example or any questions, we have to put the plus minus in front of
Wherever it's possible. Yes.
Gotcha.
Otherwise, you are losing an answer. Always remember one thing. Whatever power, same number of roots for solution, right? So in the question says solve, that means you are looking for the solution. It may say find the roots of the equation. If it's the 2 power equation, you will getting 2. If it's a 3 power equation, you'll get 3 roots. But it might happen that some of the roots are complex, not a real number. And then we say no real roots. But we'll come to that, don't worry. Yeah. No, don't worry. But I'm just saying, because whatever power, same number of roots. So if I say x square is 4, right? And you say x is equal to 2, then you're giving only one answer. But if you say x is equal to plus or minus 2, then you're giving 2 answer, which is right. X is equal to 2, half correct. Yeah. Okay, here we come. Solution of quadratic equation. A quadratic equation ax squared plus bx plus c can be factorized into x minus alpha times x minus beta is equal to 0. And then we can equate both the factors at 0 and obtain the root of the equation x is equal to alpha, x is equal to beta. Looks scary, but it's not. Right? What we are saying here is, say, for example, you got x squared minus 2x minus 8. Yeah? We have learned in previous week 4, how to factorize it. The AC method. I'm sure we have done 5 or 10 example of this, which is abundance. If you want more, go to grade 7, 8, find those books and revisit them. Okay. How do you factorize it? X minus 4 and x plus 2. Now, multiplication of two numbers is 0. What do we say? Either the first one is 0 or the second one is 0. Therefore, either x is equal to 4, yeah, or x is equal to -2. That's what it's saying. Quadratic equation, that's this, which can be factorized into x minus alpha, x minus beta. Alpha and beta just Greek alphabet like A, B, C, D. Yeah, it has been factorized when compared to 0. Either the first one is 0 or the second one is 0, leaving you with x is equal to alpha and beta. Yes, they are. They are, absolutely. But only when you are talking about the curve of quadratic. Yeah, but they are, absolutely. Yeah. Right, solve for x by factorizing. X squared plus 2x minus 3. Give it a go. We cannot afford to forget what we learned. There we are. Oops. I would modify that a bit. Swap the sign. Remember, the middle term should pass on the sign to the bigger factor. Just swap the sign in between, otherwise it's fine. Okay. Following our last week, I'll quickly revisit for one question only. We were calling it AC method. In AC method, we multiply A and C. First of all, A times C, which is -3, which being negative, we factorize the factor and subtract them, right? Okay, what are the factors of 3? Is 3 and 1, right? How you write here? 3 minus 1 is your middle term 2. So we got everything, right? So x plus minus 3 is 0. I know the factor plus x and minus x is equal to 0. X plus 3 minus 1 0. X plus 3 x minus 1, and x is negative 3, x is equal to 1. Okay? I mean, if you want one more step, you can say either x plus 3 is 0 or x minus 1 is 0, and therefore the roots. Yeah? Right, please. It's killing you all the time. Watch it. All good. We got this thing on the screen. Again, any doubt, please get in touch. Yeah. One more try. Please do it. Sorry. Make it a mantra. Make it a chanting mantra. That a chanting mantra you chant every day. Make sure of the taking care of the minus, taking care of the minus, taking care first thing in the morning before you go to bed.
I'm gonna have to start out manifesting the marks as possible.
No, you're doing fine except that little things. Just the negative.
This is root. So,
Oh, I looked it because it was only the X. Okay. Next one. Oh, I talk about it. So this is where your intercept will come, right? So given a quadratic equation, ax squared plus bx plus c is equal to 0, we call it a characteristic formula, right? Minus b plus or minus b squared minus 4ac over 2a. So if that plus or minus, that means you will have two roots, right? With the plus or with the minus, right? Okay. If the inside term is positive, so inside square root is positive, then you will have two distinct root. That means different real numbers, right? If that thing is 0, what will happen if that thing is 0? We are saying minus b plus or minus square root b square minus 4ac over 2a. The moment I say that's a 0, minus b plus or minus square root 0 by 2a, that means minus b by 2a, right? Minus b over 2a. Now, it's a quadratic equation. It should have two roots. So they are called repeated root. Okay. And if b square minus 4ac is less than 0, then you're talking about something negative inside. For example, minus 2 plus or minus root 7 over 2 or anything. Yeah, just a fencing thing or whatever. Yeah, but it can be grabbed, but it doesn't cut the x-axis is up there in the air. I'll just draw all of them. Yeah, so no roots. So no roots in this situation. When we say no roots, now we are mature enough, we say no real roots. But as a lower, shouldn't say lower, like grade 7 or 8, yeah, when we were still a very junior student, we used to say no roots. As we go mature, we say no real roots, but the roots are there. We call it complex numbers. Yeah. Okay. How does it look like in terms of graph? So a quadratic equation like this will be represented with the help of parabola. Parabola is a shape when you throw a ball up in the air, it goes up, 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 then it goes down. Parabolic shape. Yep. Trajectory thing. Right. So this is the first situation where b square minus 4s is greater than 0. It will cut at two instances and the roots are alpha and beta. Right? Whatever the roots you R1 and R2, alpha, beta, whatever you said. Here we are saying R1 and R2. In the second situation, when it's is equal to 0, it will cut exactly once, not twice. So your R1 and R2 or alpha and beta, whatever you call it, are the same. Here is different, R1 and R2. And in the third situation, it doesn't cut the x-axis. The parabola is up there in the air. Right? And that's why we say no solution.
that's a solution. The words.
Yeah, no solution. Yeah,
Yes.
no solution. Right? Okay. Right. Last term, I actually derived this formula, and everyone said, no, 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 we don't want it to see that. It's kind of like literally one and a half page of work. Yeah, this formula. No, to remember to derive the formula, like this formula, minus b plus or minus the formula itself. Yeah, it's one. Yeah, it's long. It's long. The last time I did it, and then I said, no, 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 that's fine. We'll memorize the formula. So I'm not doing it anymore. Yeah, but if anyone is interested, let me know and I'll post it on Moodle. Yeah. Yeah, yeah, it's a very basic thing. Yeah. Right. So we use this, the new formula learned. If you want to take a screenshot here, minus b plus or minus square root b square minus 4ac over 2a, right? Or memorize it, write it down. And yeah. Oh, good, Austin?
Yeah.
Yep, okay. Or look it up. Characteristic formula of a quadratic equation, you will get the same thing. Give it a go for this one. X square minus 4x plus 3. Let's use two approach. One, what we learned just now, and another factorizing approach. Yeah. I'll wait for literally 1 minute and then I'll get started with doing. Okay, let's do the new formula approach first. So our A here is 1, B is minus 4, and C is 3. The roots equal R1, R2 over whatever, minus B plus or minus B square minus 4AC over 2A. You don't have to write the formula, but if you are unfamiliar, not enough practice, then please write it. So 4 plus or minus B square minus 4AC, 16, because minus 4 square is 16, 4 times 1 times 3 if you want. I can write minus 4 square and divide by 2 times 1. This is 16 minus 12, so it's square root 4 over 2. 4 plus or minus 2 over 2. So that will give you 2 roots. 4 plus 2 is 6. 2 over 2, that is our roots or x value. Therefore, x is either 3 or 1. Okay. Next, we follow our earlier approach, another approach, what we just were doing so far. AC method approach, yeah. X squared minus 3x minus x. See, you could have go for direct factorizing if you're confident, right? I am, but I'm just showing steps. X times x minus 3 minus 1 times x minus 3. Take x minus 3 outside. Left is x minus 1. Either x is 3 or x is 1. How good is that? Two methods, correct answer. That means the methods are correct. And so are we. Okay, we'll do one more question and then quick 5 minutes break. Please do it. Again, I'll do two methods. You don't have to do two ways. I'll do it two ways. A is 8, 18, C is 9, the roots. Let's write the formula. Minus B plus or minus B squared minus 4AC over 2A. That's like 18 plus or minus, there is a minus here. 18 square. Shall we say 324? 32 times 9, 320 minus 32, 288.
Yeah.
324 minus 288, so 24 and 12, 36.
I think you didn't see that.
I've been doing this forever. I've been doing this forever. Yeah.
That's scary. So for what's it, we'll have to bring like a scientific calculator or something.
Yes, you can. You can.
So you have all one back in school. Half
of the student will die if I send it, or they will quit. They'll say, okay, that's it. Don't worry about census date. Programmable calculators are not allowed.
I know. I
Yeah.
was just saying.
Yes, 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 yes. Yep. 3/2 or 3/4. Yeah, that's what you got. Awesome. Now the other one, the AC method, right? A times C is 72. How would you factorize 72 to get 18 with the addition? Awesome. Awesome. 12 and 6. 12 times 6 is 72. 12 and 6 is 18. So 8x squared minus 12x minus 6x plus 9 is 0. Pair them. So 4x common. Yeah. 2x minus 3 minus 3 common. 2x minus 3 is 0. 2x minus 3 and 4x minus 3. That means 2x minus 3 is 0, or 4x minus 3 is 0. X is 3/2, or x is 3/4. Happy days. Both the method gives the same answer. Okay. What did you got, Daniel? Oh, you're happy with that? Okay, damn. Okay. Good, good, good. Perfect. Thank you very much. Let's take a quick, short 5 minutes break and we'll see you soon. Okay, so solution of a quadratic expression. Something for you to try again. Right. Please give it a go. I'm also doing both method. You don't have to, but I just feel like if it's done, someone will find it helpful. Yeah. Okay, I think the second one is not possible here, so I'll have to go with only one method because I cannot factorize -4 to get -4.
My teacher always
-4 and 1, yeah, sorry.
my teacher said like do the B squared take YC first and then just submit that into the full equation.
Yep, yep.
Then you cannot do
Yep, 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 yep. Yeah, 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 that's right. Yeah, so we have to stick to that characteristic equation approach because I cannot factorize -4 to get -4. Yeah. Okay, so we'll get x is equal to minus b plus or minus b square minus 4sc over 2a. So that's a 4. Did anyone get that? Daniel or Gabo? Do you get this answer?
I got to the moment with the 32 root. So how did that become 4 times root 2?
Hold on a second, please.
Sorry, what did you get?
I got to the when 4 plus minus root 32
Yeah, you have to
divided by,
cancel. Yeah, you have to really simplify that further. Yeah.
just simplify it. Okay, cool.
Yeah, yeah.
Then yeah, I got it.
Cool. Guys, ignore this. There's a bit of error here. Just one plus minus error will change everything. That's all right. Let's do it. I just forgot to change the sign initially. Okay, let's do it again. So flip the 4x squared on the other side. Plus 4x plus 1 is 0. You could do it both methods, or in fact, 3 methods. Right? First, our regular method, x is equal to minus b plus or minus b squared minus 4ac over 2a minus 4 plus or minus 16 minus 16 over 8. So minus 4 over 8 or minus half. X is equal to minus half. Another method, 4x squared plus 4x plus 1 is 0. AC method, if you call it, splitting a 4, and that is 2 and 2. Yeah, and that will give you 2x plus 1, 2x plus 1, and that will give you x is equal to minus half. Or had you realized this is 2x plus 1 square, then you get x equal to minus half. So 3 method, right? Just I didn't realize that there was minus 4x square. What I treated this question, the thing that I did just for a while, I treated it like this. And the stuff I did would have been right. Yeah, I just didn't consider a minus here. Looks like I'm getting infected. Okay, perfect. Let's keep going. What is next? Right, give this a go. Okay, so what do? Your denominator is common, which is great. And, right, so what we do? 3x minus x plus 2 over x minus 2 is 0. Since x minus 2 is already in denominator, we don't simplify it further. So 3x minus x minus 2 is 0. Thanks, Gabo. 2x minus 2 is 0. 2x is 2. And x is 1. Yeah, got that?
Somehow I did it completely wrong. That's how I got
Wait,
it.
wait, the denominator go?
Oh,
Oh, yeah, okay. Yeah,
thanks,
so
Mike. Thanks, Mike. Yeah. And what's this step? When you open the bracket, both of them should have a minus. Yeah. You can't have 2 because this is a linear. How did you get 2? Did you cross multiply? All good, Gabor? Do you need any help?
Oh, no, I just used the other one from the characteristic. It doesn't matter. Yeah, I got it.
Got it? Cool. Okay. This is good? Yeah, good. Yeah, cool. Okay. Give this a try. Thank you. Okay. Yeah, we will have to cross multiply because the denominator is not the same. So what we are saying is times this by x plus 1. That's your first term. 1 over x plus 1 times this by 3 minus x is 0. So the numerator is x and x plus 1. X plus 1 and 3 minus x is 0. Don't worry about denominator because that's when it's the same. You can combine it and take it on the right-hand side. Just focus on multiplying this. So x squared plus x minus 3 plus x equals 0 times 3 minus x times by x plus 1. So x squared plus 2x minus 3 is 0. And here you will have two approach, the characteristic formula or factorizing. I'll go with the factorizing because that's very quick. X plus 3 and x minus 1 is 0, leaving me x is equal to minus 3 or x is equal to 1. Okay. So we started the basic cross multiplication or having the common denominator. Once it becomes common, right hand side is 0, just take it on the other side. Just focus on the numerator, make it 0, quadratic equation, factorize it, and then roots. And that's why factorizing equation is important.
Like sometimes I forget if it's just like a usual x or if it's supposed to be a quadratic. So
It should turn as quadratic once you simplify it, yeah.
So it's got 2 and that is not.
Cool. Okay, I expect everyone to get this correct now. Right, so hope that is straightforward. Just remember when you are squaring, the square root goes away. Squaring on the right-hand side, collecting the x squared term, simplifying quadratic equation, and then is solving the equation. Right? There's a bit of steps involved, but the bigger are the number of steps, the greater weightage it will carry in terms of the assignment or the final exam. Yeah. Give this one a go. Another simple question, we got a square root. In order to remove the square root, take square, x squared plus 2x plus 1 minus x minus 3, simplifying. So 2x minus x is x, and this minus 2 factorizing is equal to 0. 2 factors, x is equal to minus 2 and 1. Check is not mandatory, but it's recommended. So you don't leave some answer which is not valid. Yeah. What if your x was minus 4, for example? Then you're talking about square root of negative 4 plus 3. So square root of negative 1, which is no. Yeah. But it's not. It's not the case. So we are fine. Yeah. Right. Let's keep going. Another one. Let me just remind you, if someone is wondering why we got so many questions to practice, because the format of this unit is lecture come workshop, right? So I have blended that together. Another approach could have been I teach you and then we go into the workshop model, right? Which no one has that patience to really sit in both the session. So they attend the lecture and they say, oh, we'll practice on our own. And they leave the session, right? Which is not ideal. So I have blended both of them in teach a concept, give you enough practice so you master it. Another concept, some practice, another concept, some practice, and that is working well. Yeah. Anyone got that?
I thought I did something wrong.
I got into some.
Good.
I looked up because I thought it was like, oh, something was different. What is it?
Because I was thinking x squared minus x minus 4. I was like, I can't do the method, but I completely forgot about this quadratic.
So choose one or the other. If it is solving, choose one or the other. I give multiples, so it's convenient for you to choose. But if it confuses you, stick to one of it. This will mostly work. If it doesn't, good. You say that it doesn't work. With the factorizing AC method, unless it says so, to factorize, this can be sometimes tricky or longer, but this quadratic formula is good when you have to find the roots for the equation. Yeah.
I think for the last few questions, I just got used to the factorized thing.
Yep, absolutely. Yeah. So you love one or the other, you are being biased on that. Exactly. I'm going to head up now. Oh, good. Oh, good, Daniel. Oh, he head off already. You can. Yeah. Otherwise, just leave it at third. Yep. Leave it at third. Okay, the next one. Right. Then I'm talking something fancy here. System of linear equation. Right. So it's more than one. And again, more than one equation to be solved. I know at least 1, 2, 3 method, the easy approach method, how you can solve it, okay? Two linear equation of two variables, when considered together, they are called a system of linear equations. It can be also 3 equation, 3 variable, right? Or plus minus few variable, few equation, depending on, it may happen that 2 variable and 3 equation, it may happen 3 variable and 2 equation, everything will come up with their own results. Okay? The solution to a system of linear equation is the value for xy or xy and z for each of the equation to be satisfied. Okay, and that's called the solving simultaneous equation, because you are doing it simultaneously, everything in one. Yeah. Okay. So some system of linear equation example. 4x minus 3y is 5, x minus 4y is 7. We see here that there are two equations. We call it equation 1 and 2. And obviously, we see two variable x and y. 2 variable, 2 equation, happy days, no problem. 3 equation and 3 variable x, y, and z. Bit tough days, but still manageable, right? Sorry. Oh, simultaneous. Oh, yeah. Yeah, he mentioned that. Sorry. See, that's what I said. I sometimes hear the minute thing, but then I have problem. Okay, sorry. Yeah, no, I saw that. I was trying to address him, but then he was already head up. Yeah, he already head up. Yeah. Yeah. Okay, cool. So I was so much thinking about the 3 and everything. I said, okay, you are pointing here. I said, oh, you are pointing something there. Sorry. Yep. Okay. Right. That's called Cramer's rule. Right? How we get that? We'll look at that. Solve the equation. Like there are various ways you can do it. This is one of the way, right? But it's too tricky for you to remember B2C1, B1C2 divided by A1B2, A2B1, A1C2, A2C1, right? So there should be an easier way. And gladly, there is one. Right. So like I was saying, there are 3 methods of solving system of linear equation. This is called Cramer's rule, or someone call it determinant method as well. Those fancy words you will come across again in year 3 mathematics, math 13217, linear algebra, vector, and complex number. If you're a part of Bachelor of Education, if not, by choice. Yes, but there are 2 more methods that's simpler than this one. They're called elimination and substitution, right? Right. So let's identify. Prior to that, we rewrite. There, fine. So this is my A1. This is my A1, B1, C1, A2, B2, C2. We just plug into this formula. Okay, so my X, I'll write the formula B2C1 minus B1C2 divided by A1B2 minus A2B1. And Y is A1C2 A2 C1 A1 B2 A2 B1. Okay, for X is not the A term, but B and C, 2112 B2 C1, right? So this thing here, right? 2112. The denominator is same for both. 1221. Yeah, 1221. Denominator is AB. Numerator for X is B and C. For Y, Y is already attached with the B term. So for Y, you are talking about A and C. 1221, 1221. Yeah, that's a way to remember it if you wanted to. Right. So B2, what is my B2? If you want, I can write here A1, B1, C1, A2, B2, C2. Right? B2 being 2, C1 is 8, minus B1, which is 3, C2, which is 3, divided by 1, 2. So that's like minus 2, 2, minus A2, which is 1, and B1 is 3. So 16 minus 9. 16 minus 9 is 7. 7 divided by negative 7, and that's negative 1. A1C2. 1, 2. So that's like minus 2 and 3. Minus A2, which is 1, times by C1, which is 8, divided by the same denominator. So you can write minus 7. Minus 6 minus 8 is minus 14, divided by minus 7. So that's 2. Please check it. Your answer. Right? We might make some mistake. So let's verify it. When you plug in, what will you get? 2 plus 6 is 8. That's fine. Yeah, always check the second one as well, not one of them, both of them. X plus 2y is 3, which gives minus 1 plus 4 is 3, which is verified as well. Both of them verified. Awesome. That's what we want. Yeah. Any question? Yep.
That's not the easy one.
Yeah, I mean, we got two other methods, but this is called Kramer's rule. What does he call? Silly view method. Okay. Now, this method is also as important. Sometimes when you don't want to actually solve it, but just verify whether the solution exists or not, right? Then the denominator will tell you. If the denominator is 0, then solution doesn't exist. So you don't really solve it. You just look at A1, B2 minus A2, B1. That's 0, therefore no solution. Or infinitely many solution. Yeah. Again, you can think this in terms of geometry, right? I can talk about it here, right? What happens? Blue. So there are three types of solutions. System of two equations. That's the first situation. They intersect at a common point like this one, what we did, right? Second situation, they are parallel. No solution, right? Example of such is x plus y is 3 and x plus y is 7.
Another way to figure out if they're linear or not.
If they are linear or not, linear is one power. A solution of linear? There are two methods, substitution, elimination. The third one is Kramer, the silly people's method. That's this one, the third one. Yeah. Okay. And the third situation, when the lines are overlapping, one on the other, right? Example is x plus y is 3 and 10x plus 10y is 30. Yeah, 10x plus 10y is 30. So there'll be every point is a solution, infinitely many solutions there. Yeah. Okay. Right. That's just a bit of connection with geometry. Yeah. Right. Let's keep going. Substitution method. So in order to solve linear equation or system of linear equation in two variable, what we do, from one of the equation, we make x or y as a subject. So x is equal to something or y is equal to something. Pick that up, substitute in the other equation, not the same, the other equation. That's called substitution method. There are steps, solve one equation for one variable. So like I said, make x or y as a subject. Substitute the sole variable into other equation. Say if you made y as a subject, pick up that y, put in the first equation, and then you'll have x value, put it back, that's your y value. Find the second variable, and then back substitute to get the solution. Let's look at an example. Solve the system of linear equation using substitution. That's it. So here is already given in a form where you can easily substitute, right? So I'll call this equation 1 and 2. Yeah. Substituting. Equation 1 into 2. Right? So 2 is 19. In place of y, what I will do from equation 1, I replace the value. Now we can see is all x. Therefore 2x, 3x, and 9 is 19. 5x is 10. X is 2. And with the help of this from equation 1, and in your mind or on paper, and always verify it.
didn't remember this from high school.
Mm, mm,
Yeah, but what if someone?
mm. Good. Another one. Please give it a try.
Uh,
Pick up on the equation. Make x or y as a subject. So it's already given in equation 2. X is a subject. Pick it up. Another equation. Replace it. Everything in y. Get the y value. Go back to the first equation. And that's the x value. Yeah.
when we got that, we didn't know what X was originally, we just summed the.
Yeah. It's already given in a substitute form. Yeah. Okay.
Yeah, let's check if we are going to be on some things in the accepted. Like when you label them 1 and 2, you have to say sub 2 into 1.
It's better if you do. And it's kind of a habit as well, because when you become it,
I just
yeah. It's fine, but let's just like you are into a teacher's training course, right? So after 3-4 years, whatever habit you will develop, it will come automatically. So if you're writing on a board in a classroom and you don't write the filling step, and students go like, "Whoa, miss, I didn't understand," and then you say, "Oh, okay, substitute," and then you have to insert that line. So a bit of effort now will really take you a long way. Yeah. Always think that how can I, rather than learning, because you are to teach someone within 2-3 years time, you never know, next year you might have a job. Many of the second and third year students are already having full-time employment, right? So if you are already into teacher's aid or any other teaching job, then they'll say, "Oh, is good," or la la la. Yeah. Right. So this is the next method, elimination method of substitution. So the second algebraic method of solving a system of equation is called the elimination method. We eliminate the variable. We can only eliminate if they are same. So if they are not, we make them same. How do we make them same? By multiplying, right? If say one of the equation has 2x, another has 7x, then you make both of them 14. 2 and 7, the common is 14. Yeah. And then you eliminate. Okay. Right. So these are the steps. If necessary, multiply one or both the equation by some constant. Right. So the coefficients of one of the variable are exactly the same or the opposite. Right. Add or subtract. If they are same, you subtract. If they are opposite, you add. And so that common variable will be eliminated. Then once that eliminated, that will be only other variable. Once you got it, put it back in any of the equation to get your original value. Let's look at the example. Now here, see in this question it says specifically elimination, not necessary that you have to follow it. But here it says, so we have to. Yeah. Our first step is to check whether any of the variable is same or not. In this instance, 3y is the same. So it's a boon, is a gift given to us. We don't have to multiply the equation to make them equal, right? So I label them equation 1 and 2, right? And what I'm going to do, 1 minus 2. You could have done 2 minus 1, that's fine, yeah? I'm going to write them like this, because I'm very much used to writing it this way. When we say subtract, that means changing everything. If you're not comfortable understanding it this way, just consider it that you are subtracting the left and the right part. Yeah, left with left and right with right. Okay, so what that will give you? Y will be gone. Negative 3x is 5. 8 minus 3 is 5. X is minus 5 over 3. And the same thing would have happened here. Minus 2x plus 3y. Minus x minus 3y is 5. That's gone. Minus 3x is 5. X is minus 5 on 3. Once you get your x, choice is yours, either 1 or 2. Right? I go for 2 because 2 is x alone. Yeah. X plus 3y is 3. So minus 5 on 3 plus 3y is 3. From here, 3y is equal to 3 plus 5 on 3. In other words, 14 over 3. And therefore, y is 14 over 9. Looks so bad, isn't it? We'll always question whether this is a correct answer or not. But to me, it looks like correct. I'll quickly verify it as well. How about we substitute that in? So minus 5 over 10 over 3 and 42 over 9, 10 over 3. So that's 30 over 9, 30 plus 42, 72 over 9 is 8. Yep, first equation is fine. Negative 5 over 3 plus 14 over 3, negative 5 plus 14, that's 9 over 3, that's 3, that's fine. The answer is correct. Yeah. If you can't do it on your mind, on your brain, that's fine. Do it on a piece of paper, but just make sure you put it back to verify whether the answer is correct or not. Yeah. Did the method make sense? All good, Keba?
Can I switch up the two what's it called? The two equations. So can I start with x plus 3y equals 3 and minus the
Absolutely.
2x? So it doesn't matter which I subtract. It's
Doesn't
just
matter.
okay.
So what
okay.
you are saying, rather than 1 minus 2, you are saying 2 minus 1? Yeah, that's what you are saying?
Yeah.
Absolutely. Absolutely.
Okay, that's nice.
See, in that instant, what you would get? 3x is equal to minus 5. Rather than minus 3x is 5, you would get 3x is equal to minus 5. Yeah?
Yes.
Good. Let's keep going. Few more slides. Give this one a try. Let's adopt it extra. Right, another kind of a very easy question, I would say. Equation 1 and 2. I will simply go 1 minus 2. I feel that everyone is comfortable watching it this way. Yeah. So I do it. X is gone. Y is 5. Y is 5. Pick up any of the equation from 1. X plus 10 is 8. And therefore, x is minus 2. Check, check, check. Yeah, it's a good habit to check. Minus 2 plus 10 is 8. That's right. And minus 2 plus 5 is 3. That's right. Yeah. And therefore, your solution is x is 2, y is 5. Okay. You know what does it mean? It means if there are two lines, okay, they would intersect here. One of them is this. I don't know. Like I'm just saying this point is minus 2, 5. Yeah, so that's your line 1. That's your line 2. That's an intersection point. This is where they meet somewhere minus 2, 5. Only one intersection point. Yeah. There's only 3 cases. One intersection, no intersection, or infinitely many intersection point. Like identical line, one on the other. Yeah. Cool. Dependent system of equation, right? Oh, okay. So what is a dependent system of equation? When solved, the result in both variable being eliminated and a true statement occurring. That's what I said, identical equation. X plus y is 3 and 2x plus y is 6. 2x plus 2y is 6, yeah? Simply multiplied, one equation multiplied with the other, like constant multiplication. This system, both equation representing the same line, not a parallel line, same line. The solution is essentially infinite number of solution of x and y. They are dependent on one another, and graphically, the solution is the line itself rather than one point of intersection. This is how it looks. So you got the coordinate system. The red line is one of them, and see the other line coming. You won't be able to notice. See that? Yeah, that's the line. The line is just the same point. Every point on a line is a solution. Black one is the line, and they merge one on the other. You can't really see two lines. I just overlap red and black so we can see it visually, but it's a line. It doesn't stop. It's not a line segment, not a part of the line. Line is infinitely stretched, right? It doesn't end. And that's why we've got two arrows with the line. How do you represent? With two arrows. So you keep on going both ends. So you can't see. Yeah. Right. Then inconsistent system of equation, parallel equation, no solution. Inconsistent system when the solved algebraically results in both being cancelled and a false statement occurring. I'll give an example here. The example is coming, but it looks like not. X plus y is 5, and let me say 3x. When you try to eliminate, x and y both gone, 5 and 15 both gone. We try to multiply by 3. Yeah, becomes 3x, 3 by 15. When you try to subtract, 0 is equal to 0. Right? But up here, it will look a bit differently. Right? So what happens? The graphical representation of inconsistent is a pair of parallel lines. See how they look. No intersection point. Yeah. First line and second is a parallel line. Example. For example, I mean, not this one, but just in general, x plus y as 5 and 3x plus 3y as 14. When you try to eliminate, you will get 1 is equal to 0. X and y both gone. It says both of them being cancelled and a false statement happening. Yeah. If you look at that, divide by 3, how does it look? X plus y is 14 over 3. How is that possible? Equation 1 says x plus y is 5. Equation 2 says x plus y is 14 on 3. Impossible. And that's why they don't have any solution. Right? Well, this one, you times this by 3. That's practically the same line. Okay? So dependent or infinitely many solution, identical line, inconsistent or parallel line. And when they intersect, when you have a solution, it's something that we just discussed. This thing here, right? That's called consistent or one unique solution, this thing here. Yeah, two lines intersecting at one point. Okay. Not long to go, don't worry. There are often practical application of the problem that requires solution of system of linear equation to find the answer. Right? Can be summarized as below. Read the question carefully. That's called mathematical modeling, where you convert a real life situation into mathematical equation, solve it, and put the solution into words so it makes sense. Yeah. Read the question and determine what is required and the condition. Clearly define two required knowns for equation. Translate into equation using defined variable. Solve it with substitution, elimination, or other technique. Check the solution or verify the solution and translate the solution into written answer, right? Okay. Go for it. Two salt solution, 21 and 5% salt respectively, are available. To make 1000 ml or 1 liter of the salt solution with 11% using this two solution, what amount of solution from each of these must be mixed together? Think. Think, 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 think. Right. The two solution, 21 and 5% of salt respectively, are available to make 1000 ml of salt solution that has 11% of salt. Using two solution, what amount of solution from each must be mixed together? So say from the first one, we got X, and from the second one, we got Y. So what we know, X plus Y, when they are added, you wanted to make 1000 ml, isn't it? Right? But how much is X, the salt contained? Is 21% or 0.21 or 21 over 100? 0.05 for the Y, and you want 0.11 of 1000. Right? Now, the easy thing is you times everything by 100. Right? So 21x plus 5y. This is 11. 1, 2, 3. First equation, second equation. What you do, you eliminate, but they are not equal. So what I do, equation 1 times by 5 minus equation 2. Or equation 2 minus equation 1 times 5. So what I get, 5x plus 5y. Okay. Subtraction, 21x and 5y. On the right-hand side, I got 5,000 minus 11,000. How did I get 5,000? Equation 1 by 5 times by 5. Yeah. So 5x minus 21x is minus 16x. Y is gone. 5 minus 11 is minus 6,000. That would give me x is equal to. See, if you're not sure of this higher part, get rid of the 4. Right? If you don't want to do it on calculator. So that will give you 4,000. No, sorry, 1,500. My bad. Yep.
It's 0.11 from 1,000. Isn't that 110?
Yes, but we multiply by 1,100. Because we had
Okay.
0.11,
Okay. That's yeah. Okay. Cool.
Good question. No. That means we are thinking. If you ask question, I feel happy. I don't say, oh, good or bad. I'd never judge the question, but at least I know that you are thinking about it. You are with me, right? And something doesn't make sense. You said, oh, that is something that I need to ask. Please, yeah, always ask. From 1, your y will be 675, right? But remember the method that we discussed? Translate the solution into written answer. Your x and y is assumed by you, right? I got 3 candidates with me. Fiona would have assumed X and Y. Austin might have assumed C and D, while Gabo might have assumed M and N. Individual choice. Some math nerd would have assumed alpha and beta, right? So we should always write the final answer, what we mean, right? What is X related to? 21%, right? Therefore, 375 ml of 21% and 675 ml of 11% are mixed together. Okay, that's it. That's your final answer. Don't leave the answer as X and Y. You need to complete it. X and Y is assumed by you. It's not a part of the question. Okay.
That just feels like an exam question. I'm worried.
Do you want
to know that makes sense?
Yeah, when you look at the solution, it always makes sense. It's only that we have to do it, then we kind of struggle. Yeah. Okay. Give this one a try, please. Cool. Now this one. Again, my choice is X and Y. Yours could be A, B, C, D, M, N, E, F, K, L, whatever, right? But I'll write X, which represents the 5 cents, right? And Y, which will represent the number of 10 cents coin. To be precise, they are the number of coins. Okay. Now, I have total 35 coins. Therefore, the number of coins is 35. So X plus Y is 35, equation number 1. Now, this is about value, right? How much value does a 5 cents have? 0.05, right? If there is only one coin, then it's 0.05. If there are 10 coins, 0.05 times by 10. We don't know how many are there. That's what we are trying to find out. But we know there are X. So 0.05, which will be times by X. Similarly, 0.10, that's 10 cents, times by Y is the value, which is 2.5. Easy things is, you could have multiplied by 10, but say we got 0.05, so we times it by 100. Okay, so 5X plus 10Y is equal to 250. If you want, you could divide by 5. I love that. You make the equation smaller. Why? No more multiplication, simple, easy equation. Subtraction can be done very easy. I'll go 2 minus 1. And therefore, X plus 2Y minus X plus Y is 50 minus 35. My Y is 15. If my Y is 15, my X is 20 from any of the equation. And therefore, 25 cents coin. Don't say 25, 25 cents coin. And 15 10 cents coin. That's a total 35, and the value is 2.5. Easy? Obviously, once we do it, it's easy. It wasn't a difficult question. Like that's yeah.
Seems like the hard part is like just forming the.
Yes, yeah, and then it's just solving it here. Yeah. Okay, I'm sure you should get it now.
I'm doing that.
Okay, so if you're not doing, then I will explain why. How much 20% solution? The bracket is to inform you. If that confuse you, don't worry. When I say 20% solution, that means 20% of the content, rest is other mixture. With alcohol is a water, yeah? So 20 and 80 in proportion, and 50% solution. So one is a mild, one is a strong alcohol content, must be mixed to get 12 liters of 30% alcohol solution, right? When you go to pub or bar, they kind of maybe using this formula, knowing and unknowing a different story, right? So following to what we did earlier, what we know that 20% solution, let's call it X, the content, yeah. 50% solution, let's call it Y. What do we know? The total is 12. That's what we know for sure. Other thing, 20% of solution of X and 50% of Y, when they are mixed together, the combined concentration is 30% of 12. 30% of X plus Y or 12. Yeah, I times this by 10 to get rid of the decimal, right? So 0.2 or 20 is the same thing. 2X plus 5Y is 3 times 12 or 36. 2X plus 5Y is 36. Equation number 2. Now what we do, equation 2 minus equation 1 times by 2. You cut it down times by 5 to you. 2x plus 5y minus 2x 2y is equal to 36 minus 24. 2x is gone, 3y is 12, y is 4. If y is 4, x is 8. That's it. Write down the solution in words. Therefore, we need 20% of What is 20%? 8 liters. Yeah. 20% solution is 8 liter and 50% of 4 liter
I
mixed up.
simple math, I somehow do. So I times the 0.3 into 3, right? So it should be 3 times 12. And that should be 36, right? I thought it was 48 for some reason. I can't believe doing math like this.
You know what? I tell you, we are bound to make mistake. It's normal. Once you cross-check it, it will not match. So always spare some time to cross-check it. Your equation will have horrible solution, or it will not solve, something really fancy will happen. And then you're like, oh, something is wrong. Go back every step. If you still can find it, redo it. Sometimes redoing it, you will pick up, but looking at the same thing you want. Yeah.
I'm just kind of surprised that I got basically the same numbers. I just got them on the wrong sides anyway. So I'm just like, how did this happen?
When you took it away from each other and you got negative 24 as the increase.
36 minus 24.
12 minus 36 and it's negative 24. Why did?
No, I did 2 minus 1. The 36 minus 24. Okay, let me come there. Okay, so it's a Kahoot time. Get ready. Those who are watching the recording, you can also do it as a Kahoot. I mean, pause and play, look at the question before I reveal the answer, pause it. Don't look at the next, Yeah. Okay, let's start. Two correct. Correct? Okay. Are you?
Well, I would hope so. It was always 3 of us.
Anything to explain? I think it's just factorizing. Then did you get wrong, Gabriel?
Yes, because I got panicked and just pressed one button. But then I seen I have time to do it.
Oh, that was 90-second. Yeah.
Yeah, I seen it after.
Okay, that's all right. Good job. Good job. Okay. Very good, Austin. Take your time.
Oh.
No.
Because it's the only one with necklace.
That's not what I thought.
Oh.
I thought about the 2 up the front as well as the 18 and the 8.
Do we know what the question meant?
Yeah.
Explain.
Um.
Explain.
Yeah.
That's just all I thought was to factorize it, but
You don't have a good technique so far of factorizing a cubic. Yeah, and that would take definitely more than 60 seconds. Yeah. What is the definition of factor?
Split.
Split it. And what happens? If you put it back, what happens to? Does it satisfy the equation? That's a factor, isn't it? Yeah. What do you mean by satisfy? The left hand and right hand kind of balance, isn't it? So, right, don't worry. So, x is equal to x plus 2. If it is a factor, x is equal to minus 2 should satisfy the equation. If x plus 3 is a factor, then x is equal to minus 3 should satisfy the equation, right? Or the next x is equal to minus 1 or x is equal to 2. Now 3, don't even try it because when you plug 3, the last term is 8, it won't even match. 1 is my last choice because then the other factor has to be 4 and 2. I would always go with x plus 2 or x minus 2. X minus 2 lot easier because x minus 2 that I'm replacing x is equal to 2. Replace in this cubic equation x is equal to 2. So that's like 8, 16 minus 44. 16 minus 44 is minus 28 plus 36. That's plus 8 minus 8, 0. Happy days.
Calculator. Just saying.
I have to look somewhere. So, yeah, so x minus 2, that means x is, yeah.
And I don't stress about that in exams because I can answer other questions faster.
Absolutely. There is no good or bad, right or wrong approach. It's just what you are comfortable with, yeah. So x is equal to 2, satisfy the equation, and that's why that's the correct option, which none of you got. So sorry for that.
Yes.
3 more.
That wasn't us.
Bravo, Kepler.
Can't do what you said before. We can't do it.
Damn it! 50/50s.
I thought it was the negative.
Who got it right?
I had a feeling it was going to be red anyway. Because
Okay.
That's what my brain was leaning towards.
Gabor is not winning or hitting, lose or right. Why did you do it so early? You did it so early.
Oh, wait. Oh, no.
You
Right.
get the most points by pressing it.
But what if it's wrong?
Something's better for science.
Yeah. Well, what I said, right? If
Oh.
x minus 1 is a non-factor, what the other one, right? So what you are doing is simply, I mean, you can ignore the fact that x minus 1 is a factor unless you are doing on a piece of paper by long division, right? What you can do, which of them could be other possible factor? Try with 1, because then you're replacing x is equal to minus 1, right? Replace it here. So that's 2, that's plus 4, that's minus 23. So 6 minus 23 plus 11 plus 6, does it equal 0? If not, that's not the answer, right? Don't worry about 3. We got 6, so 3 could be an answer as well. Try with 2, try with minus 2, try with minus 3. One of them should work. That's it, right? Okay. 2 right answers.
That's the way it is.
Okay, 2 more, 2 more. Come on.
Yeah. Okay.
Unless I was completely wrong. I was completely wrong, right?
All of you were. Solution. Yeah. I said it just now. Root or factor or solution is the same thing. Right? Minus b plus or minus square root b square minus 4SU2. Let's do it on our brain. It's not difficult. Just hear me out. Okay? Minus b plus or minus b square minus 4SC root over 2a. B is 3. So minus b will be plus 3. Right? Plus or minus square root 9 minus 4 is root 5. 3 plus or minus root 5 over 2. That is 3 over 2 plus or minus root 5 over 2. Now root 5 is near to 2. I know the value is 2.26. Oh no, 2.21, 2.21, 2.22, something like that. Divided by 2 is 1.11. 1.5 plus or minus 1. If you can't do it, use a calculator. It doesn't prohibit you using calculator.
Oh,
I took it out to do
Yeah.
the text. Have this put back.
Yep. So 1.5 plus or minus 1.1, approx. So 2.6 or the other one. Yeah.
somehow did like the, I somehow did the like quadratic expression for like b squared. plus
That's
That's
minus
what
that,
Exactly.
there. Yeah, that's
And
what.
I'm surprised I did it, but I don't know how I ended up in like, okay, so one of them is definitely in the negatives.
Say the same. Last chance. Last
Oh.
chance.
This one's so
Pick one. Just pick one.
I was, but I just couldn't process it.
5-second margin. Yeah. Choose a 5-second margin. Within last 5 seconds, if you don't know, just pick anything.
Yeah.
If you wait for
That's
1 or
fine.
2 seconds, yeah. Okay. So anyone got it right?
I somehow got it right.
I knew what I had to do. I just
Yeah.
I just can't. Like when I know there's a pressure, then I just can't do it.
Well, the last question. But no, it's good. Everyone is on a podium, so hooray. Good job.
I got a point.
See, we don't look at, see, if you have to post this on Insta, right? Don't write the score. Right? Get rid of the 0, 1, 5, 1, 6, and 1, 3, 5, 8. Then you have still, that's me. Yeah, you can only say that. Now, good job, guys. Thank you very much. What I'll do, I'll shut this off now. Yes. Stop sharing, stop recording.